Okay, welcome to 1.1 to 1.4 physics course practice. Let's go over these a bit quickly, similar to the AMS, so I'll be going through them a bit quicker, except for some new questions. Which statements about temperature and the sensation of hotness are true? A person experiences a sensation of hotness when heat flows into their hands. Okay, true. A person experiences a sensation of coldness when heat flows into their hands. False. Temperature is the degree of hotness of a body. صح. Okay, the degree of hotness is temperature. The sense of hotness can be used to measure temperature. لا. Okay, the sense of hotness is what you feel. What you feel, can you just measure temperature off of what you feel? No, you need a proper way. The sensation of hotness is a quantity that can be measured. Same thing as the last one. You can't measure a sense. Okay, so I'm sure many of you are confused. طب وليد, in the exam what came? Which is true about the heat? Okay, careful. Heat sensation. So the physics regional decided, like I told you, to play with the words. As I told you, he does every exam. That's the only reason you guys get it wrong. Because he plays with the words. Realize how here it says hotness. Here it says heat. Heat can either mean hotness or coldness. So the two correct options about which is true about heat sensation were heat sensation is felt when heat, or no, it was energy, صح? When energy enters our body, and heat sensation blah 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 is felt when energy leaves our body. Okay, so just remember this, because I'm pretty sure he will bring it again in the periodic, so you don't get it wrong. It's felt when energy leaves our body or energy enters our body. Okay, a fixed amount of gas is sealed in a rigid container, volume 10 centimeter, initial of the gas minus 70, blah, 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 blah. In order for the pressure law to be applicable on a fixed amount of gas, which of the following must remain constant? Let's go back to our notes over here. Let me open them. Over here. Let's start with our laws. Let's go back to the laws. We said Boyle's law is when temperature is constant. Do you remember, guys? PV over T. Pressure law is the one when pressure changes. Okay, for pressure to change, okay, which one is it? It's either V constant or T constant. We know if it's T constant, then it's P1 V1 equals P2 V2, and that's not the pressure law. We know that's Boyle's law, because temperature, boiling, boils, right? So, since it's not T constant, then akid is going to be what constant? V constant. If V is constant, then P1 over T1 equals P2 over T2, right? Remember this rule? Okay, here pressure is changing. That's how I told you to memorize. Pressure law, pressure changes. Temperature constant, it's P1 V1 equals P2 V2. Temperature constant, yani Boyle's law, temperature. And what's the last one left? It's Charles' law. Okay, let's go back to Chrome. So what needs to be applicable for the pressure law to be applicable, whatever? Okay, we know that the volume must remain constant. Okay, then here they ask you to apply it. If the pressure of the gas becomes 1200, what will the new temperature in Celsius be? We know we can't solve in Celsius, so let's solve in Kelvin. Okay, we know that the V is constant, PV over T. V constant, yani P1 over T1 بتساوي P2 over T2. Okay, P1 is 800. Okay, T1 is negative 73 plus 273 to make it Kelvin will be 200. Okay, equals P2 قالوا لنا 1200. Okay, over T2, which is we don't know it, right? So when you do this on your calculator or whatever, cross multiplication, I don't know how you solve, depending on yourself, 800 over 200 equals 1200 over x. Shift solve, you get 300. So this is your temperature in Kelvin. Careful, they asked in Celsius. Okay, so how do you change this into Celsius? You do minus 273, you get 27. Question 3. Okay, we have to know if it's thermometric or non-thermometric. Remember, a thermometric property is a property such that it can be changed and measured. Volume at a constant pressure, we know volume of a gas can be changed, and we can also measure it. The mass of a fixed amount of gas, we know the mass is always constant of a gas, so it's non-thermometric because it cannot be changed. Okay, hardness of an egg, we know it's non-thermometric because you can't measure it and you can't change it. Once you cook it, you can't bring it back. The length of mercury in a tube, we know we can measure it, length, and you can change it. If you heat it up, it changes, it expands and contracts. That is for 1.5, 1.7 for another video. Okay, this is a new question. Its rule I don't think is in the book, but I will give you the rule. Okay, we have 300 Kelvin, that's T1. The average speed is 1900. Then they gave us T2 and they want the new speed. Okay, so we haven't really worked with these temperatures وما بعرف شو. I'm gonna give it to you. The rule is V1 speed, velocity 1 over velocity 2 equals radical. Okay, not T2 over T1. No, that's chemistry. Okay, in physics it's T1 over T2. Okay, so this is equal to V1, which is 1900, over V2, which we don't know, it's x, the new speed, equals radical T1, which is 300, over hold up. Yeah, my fault. It's equal to T1, which is 300, over T2, which is 1200. Okay, and then obviously if you cross multiply, you're gonna get, you can square both sides, or if you have these types of calculators that can solve the equations, you're gonna put 1900 over x equals radical 300 over 1200. Take this shift solve, you get 3800. Okay, make sure to memorize this rule. If you put it in your written part, if it comes written, akid they will give you 100% correct. Don't forget the unit, meter per second. Don't forget significant figures, don't forget units. Every video I'm gonna keep on saying this until you guys get it in your head. Unit, significant figures, unit, significant figures. A fixed amount of gas is kept at temperature T. The average speed is V, where the kinetic energy is E. Okay, the temperature of the gas is quadrupled. What will happen to the kinetic energy? What did we say? We said that average kinetic energy is directly proportional to the temperature in Kelvin, to absolute temperature, right? So what happens if you multiply by 4 here? You're gonna multiply by 4 here. Okay, so what's gonna happen to the energy? The energy is gonna be times 4. طب you can say, طب وليد هلا what about the speed? نحن what did we say happens to the speed? The speed, we have the rule V1 over V2 equals radical T1 over T2, right? Okay, so V1, V2, whatever, okay? We know that temperature 1 is T, okay? We can just call it T. And then temperature 2 is 4T, right? Okay, so you can square root this. Okay, you're gonna get V1 over V2, right? Equals the square root of 1 over 4. It's gonna be 1 over 2. Okay, you can solve it like this. V1 over V2 equals 1 over 2. And then you can get, after you cross multiply, that V1 over 2 equals, no, V1, no, sorry, not like this. Ya Allah. V1 times 2 cross multiply, I don't know why I did over 2, times 2 equals V2. Okay, so your V2 equals 2 times V1. They called V1 V, so V2, new V, is equal to 2V. You can do it like this, okay? Or you can just do quadruple, yani times 4, and just find the square root of that. Okay, you can do that, that works as well. But this is if you want to go along the formula way. If you want to just do it quadruple times 4, also you square root, then it becomes 2V. You can do that as well. Okay. The reason for this, by the way, is because kinetic energy is equal to half mv squared. Okay, so it's always v squared. You know, that's why you square root it. That you can also apply it for the previous question, by the way. But I wanted to use the formula because if you write 300 to 1200 is times 4, so you quadrupled. So what's the square root of 4? It's 2, so then you just multiply by 2. This works as well, but like if it comes in the written, I don't want you to do that. Okay, they won't bring something like this in the written, but something like the previous question they could bring. Okay, till now I'm still convinced for written they're gonna get something to do with P1, V1, whatever, or something to do with Q equals MC delta T. Okay. Don't forget to watch the notes videos. At the end of the 1.5 to 1.7 notes, I included a question that I think will come in the written part, and even our head of physics told us he thinks it's gonna come in the written part, okay? So make sure to watch the notes videos, they're very important. The regional head of physics kept on stressing about doing the book. My notes is basically the book, yani. Okay, please make sure to do them. Watch the videos for them. What does a thermocouple measure? We know thermocouples measure temperature. Which wires are made of the same material? We know it's wire W, wire Y. This is a good question. Make sure you know it, huh? What does this meter in X measure? It's current, right? It's a galvanometer. Which statements correctly describe the thermocouple? They have low heat capacities, they have relatively high precision, and they respond to changes in temperature very quickly. It should be somewhere here. The galvanometer. Here, 3 advantages. High precision, it's very sensitive, and it has a low heat capacity. So very sensitive should be one of them. Yeah, it should be here, but they didn't write it. Question 7, the absolute temperature, يعني make it into Kelvin. How do you do it? We just add 273. Question 8, okay, في كتير calculations behind the quiz. Okay, a fixed amount of gas is kept at a temperature 25. It's constant temperature, so PV over T. Constant temperature, خبيها. What are you left with? PV. So P1 V1 equals P2 V2. Okay. Initial pressure is 1, volume is 12, pressure becomes 3. Okay, let's see what are they asking. They want the temperature in Kelvin. How do I make it Kelvin? Plus 273, 298. To find the volume, final volume, what law do we use? We use Boyle or Boyle's law, whatever. However you type it, it's correct. How do you find the final volume? P1 V1, so 1 times 12 equals P2 V2, yani 3 times V2. You get V2 equal 4. Question 9. Okay, the initial pressure of a gas is 8 and its volume is 15. For Boyle's law to be applicable, what has to be remain constant? We know temperature constant. But كمان you say mass. Okay, if you see mass is always constant أصلا. Okay, so it doesn't really make a difference. The main part here is temperature. أكيد, will you say temperature and pressure constant? لا, because temperature and pressure constant شيء تاني. If the volume of the gas is increased to 30 centimeter cube, what will the pressure become? So they gave us V2. We have V1, we have P1, they've done P2. We do P1 V1 is P2 V2, 8 times 15, 120. 120 divided by 30 is 4. Okay. Question 10. A fixed amount of gas is 27 degrees Celsius, has a volume of 8. The pressure of the gas is kept constant and its absolute temperature is half. Okay. To find the volume, what do we need to do? Okay. PV over T. Pressure is constant. يعني سكرت على pressure. Is it Boyle's law? أكيد لا. Is it pressure law? أكيد لا. Why not pressure law? لأنه for the pressure law, the pressure has to be changing. Okay. Type, what are we left with? We're left with Charles' law. And I don't know, let me see on the other answers. Yeah. If you're trying to be fancy in the exam and put the apostrophe, make sure you put the apostrophe after the S. You know, some people don't know this still. I know you're grade 11, most people know this. But if you're putting an apostrophe and there's an S, you put it after the S. Since the S is part of the name. هلا صرت عم بعلمكم grammar. بس anyway, put the apostrophe after the S in case you want to put it, or you can just put Charles. Anyway, yeah, we're going to use Charles' law. And how will we do it? We cover our pressure. We're going to be left V1 over T1 equals V2 over T2. شو هي V1? V1 هي 8. T1 هي 27 plus 273, which is 300. Okay. V2 نحن ما بنعرفها. We're trying to find it. T2, they said it's half of the first one, so 150. You cross multiply and you're going to get 4. And I'm not going to do it in the calculator because it takes time. I think خلاص everyone now at this point should know how to cross multiply. We've been doing this stuff, these types of chemistry and physics questions since grade 10. The initial pressure is 8, volume 12, temperature 27. Okay, for Charles' law to be applicable, we just did it. What must be constant? Charles' law, yani V1 over T1 equals V2 over T2. Okay, what must be applicable? What are we missing here? Pressure, yani pressure constant, okay? Pressure وشو دايما we say mass. Okay, if you see mass, don't get confused and get scared وما بعرف شو, start panicking. Pressure and mass عادي, mass is always constant anyways. If the volume is changed to 18 at a constant pressure, what will the new temperature be? Let's see. V1 is 12. T1 is in Kelvin is 300 because 27 plus 273 equals V2 18 على new temperature T2. Okay, you cross multiply وبيطلع لك something in Kelvin. I'm going to do this one because you get something in Kelvin, you have to change it into Celsius. Okay, they want the answer. Be careful, look at the unit, it's Celsius. They want the answer in Celsius. We're going to put our answer, we're going to subtract by 273 at the end. So 18 على X shift solve equals, you get 450, but remember your answer that you got now is in Kelvin. انتبهوا, it's saying degrees Celsius, be careful. Minus 273 177. ماشي. Question 12. A fixed amount of gas, volume 20, temperature 1 is negative 23, pressure, is this? It's then heated to 27. To find the final pressure of the gas, okay, one needs to apply the pressure law. Okay, they didn't say anything is constant, but they told you they want to find the final pressure. Yani P changed, right? So the P changed. What rule do we use when P changed? The pressure law. Okay, what's the other? Okay, write it like this, pressure law. Okay, to find the final pressure of the gas, how do we do it? We use the pressure law. What's the pressure law? P1 على T1 equals P2 على T2. P1 هي 600, T1 هي 27 plus 273 which is 300, P2 هي بتكون the new pressure we don't know it, T2 هي شو قالوا? What happened to the temperature? Oh لا sorry. The T1 is not 300. It's T1 is negative 23 Celsius plus 273, which is فهيدي بتصير 50 to 250. P2 over T2 27 plus 273 300. Okay, so I'm not sure if my values are correct. Let me check. 600 over 250 P2x يعني على 300. Shift solve equal. Yeah, 720. Okay. Question 13. خلصنا بسرعة هولي. Okay, volume 20 is initially at 7 degrees Celsius, whatever. Okay. Remember that they say a fixed amount of gas of volume. Okay. Sure. The temperature of the gas. Okay. Here they gave us V1, gave us T1, gave us P1. The temperature of the gas is raised to 147. Ooh, the pressure command changed. So temperature changed, pressure changed. Command volume changed. Remember, our equation is PV over T. So even if nothing is being constant, you can just use the equation P1 V1 over T1 equals P2 V2 over T2. Please don't panic, okay? Relax. Just remember the formulas you have. P1 is 2.5. V1 is 20. T1 in Kelvin is 280. P2 at the pressure doubled, يعني 2.5 double of 2.5 is 5. V2 we don't know it. T2 صارت 147 plus 273 بتصير 150 plus 270 2420. I think 420. Do this on your calculator. 2.5 times 20 2.5 times 20 fraction لا اوكي حط fraction اول 2.5 times 20 تنزل لتحت بتحط 280 go equal 5 x تحط الفراكشن over 420 shift solve equal x equals 15. Question 14. Okay, this is a bit easier. ماشي في formulas. What's this point over here? Since we're placing it with boiling above boiling water, not with boiling water, above boiling water with the steam. هيدي بتكون steam point. What is this steam at 100 degrees? أكيد هيدي boiling water. What are we applying? أكيد we're applying heat to boil the water. يعني common sense. What are the hazards of calibrating a mercury thermometer? أكيد the extreme heat since you're boiling. Fragile glassware in case the tube breaks. وكمان toxic mercury. Remember that mercury is toxic. Okay. In order to plot the point at 0 degrees Celsius, what do we place it in contact with? Melting ice. Okay, melting ice or crushed ice. Careful about the word play. والله أنا بحس I feel like he will play with the words, even more questions. Mr. I won't say his name, but the physics region, he always he likes to play with the words. Okay, and he put these trick questions وما بعرف شو. In order to plot a point 100 degrees Celsius شو بنحطها? You place it in contact with steam. With steam. إذا حطه with boiling water أكيد غلط. Wrong. Okay? With steam of boiling water. If the length of the mercury is okay, عندنا الجراف هون is 22 centimeters at the temperature. How much is the temperature? So we go to 22. It's over here. This is 5 blanks. So each blank is 2. So 22 will be here. بتطلع لفوق. Go up. Go to the left. This didn't come in AMS. Maybe they bring it periodic. Maybe written حتى. It will be 60. The size of 1 degree Celsius. To remember, to find the size, you do the length. Okay, the lengths minus each other divided by 100 and you get 0.02 0.2 you get, not 0.02. 0.2 centimeter. Within, yeah, millimeter, and from centimeter to millimeter, you just multiply by 10. You get 2 millimeters. Question 17. Okay. They want us to label the graph. أكيد, since we're calibrating a thermometer, the bottom one will be 0, the top one will be 100. قالوا إنه the lengths, the ice point is 10 centimeters, so أكيد بتحط ال 10 هون. The steam point is 50, so you put this point is the steam point, which is 50 centimeters. Okay, then they say when the liquid is put into a thermometer at temperature 50 degrees, how much is the length? So بتروح عند ال 50. How many blanks do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. يعني each one is 10. No, you have 10 blanks. It's 100. So 100 divided by 10 is 10. So each blank here is 10. 10, 20, 30, 40, 50. And you're going to go from here. Okay. Well, you go to the graph and you go down. And I'm here. How much am I on? It's how many blanks here? 1, 2, 3, 4, 5, 6, 7, 8. 8 blanks. How do you know how much each blank is? It's 40 in between 50 and 10, right? 50 minus 10 is 40. 40 divided by 8 blanks. So each blank is 5. So 15, 20, 25, 30. So I'm on 30. Okay. At grade 11, at this point, everybody should be able to know how to have a scale. Scale, يعني to count how many blanks in between and to know how much to put for each blank. You're going to need it for chemistry written when you're drawing graphs. 100%. You're going to need it. If you don't know already how to find the smallest graduation, يعني discounting blanks and dividing by that to find out how much each blank is, you need to know. On the Celsius scale, how much is the ice point? 0, أكيد. How much is the steam point? 100. And both are defined for the atmospheric of how much atmospheric pressure. Pressure, ATM, is equal to 100 kPa. Memorize this, please. Okay? If not in pascals, it's 1 ATM. Okay? Or you could say 10 to the power of 5 pascals. Okay? Whatever. Depends. Okay? 100 kPa, 10 to the power of 5 PA. It doesn't really matter. Question 19. What is the name of the lower fixed point? أكيد, we call it the ice point. What's the temperature of it? 0, أكيد. How do we reach it? We place it by putting it in contact with melting ice. Okay? Or crushed ice. What's the upper fixed point? Steam point. What's the temperature of the steam point? 100. How do you find the upper fixed point? You put it in contact above boiling water. Okay? I'm going to keep on stressing on these every time. I'm going to say it every single time. Okay, this question came and then they asked what property of mercury is used to measure the temperature. Well, the answer was volume. I don't know why many people got this wrong. Volume of the liquid. Okay, what thermometric property was used or something like that. Something like this. Okay, same picture by the way. The answer was volume of liquid. I don't know why all of you got it. Not all of you. Many people got it wrong. Just for the periodic, if they get it, please make sure to put volume. Like this, خلصنا 1.1 to 1.4. Thank you so much for watching. Good luck.